Hey, welcome to 9-4, everybody. In 9-4, we're going to talk about probability. And specifically, we're going to talk about something called a binomial probability. And if you'll recall, we worked a right good bit on something called the binomial expansion. Now, the binomial probability theorem that I'm going to show you in just a minute follows a binomial expansion. Okay? It turns out when you do these binomial probabilities, they answer questions that sound daunting and really hard. And this theorem has a nice way of making them pretty simple. And I think you're going to like this. Now, these do come up on our AFM test. So let's take a look at how this theorem looks. In this video, we're just going to basically introduce it and outline the components and how to read this table. And you definitely need to write this formula down. And I know it looks daunting and horrible at first. Okay, so let's just read through this thing here and see if we can wrap our head around what they're saying. All right. Binomial probabilities. Here's the theorem. It says, suppose an experiment consists of a sequence of n repeated independent trials. Now, there's some important language in there. Independent trials need to be discussed. And what pretty much like this. Okay, if a subsequent trial doesn't have an effect on its preceding trial, it's independent. For example, flipping a coin. You can flip a coin as many times as you want. The previous subsequent flips have nothing to do with previous flips. In other words, they're independent trials. So coins tend to fall into this category pretty quick with binomial theorem. Now, before I get too far along there with the independent thing, because we do need to talk about that some more, it says each having two possible outcomes, A or not A. Now, I jumped on the coin thing pretty quick there, but that's the perfect example. It has two outcomes usually when you flip a coin. We don't ever think about it landing on the edge. It's going to land on the heads or the tails, usually what they say. And it's either heads or not. Right, so if you were going to calculate a probability of a head, it could be a head or not head. All right, now let's get back to independent for a second before we just break into the rest of this, because that's all this video is us trying to take a look at this formula and explain how to read it. And I'm going to do 3 examples in other videos, but first let's break this language down. All right, so another type of frequent problem that comes up in these things with this binomial theorem, where you can break it down as A or not A, and it has to be independent, would be a multiple choice test, right? If you're going to guess on a multiple choice test, well, if it has 4 options A through D, it could be correct or not correct, right? If you're guessing, the probability of a correct selection would be 1/4. Not correct is 3/4. All right, and keep in mind that that's why this 1 minus p works here. So what they're saying here is if on each trial, the probability of A, now we're going to call A a success, is p, and p of not A, that just means, hey, it's the other, it's complement, because remember, probability sum to 1. Like, for example, with the head, it's 1/2, because there's 2 outcomes, favorable outcomes ahead, there's 1. And not ahead is also 1/2, and they have to sum to 1, and this forces that to happen. Okay. Then the binomial expansion, and this is how they show it. And no, we're not going to derive this. I don't think it would be really worth it. We'd have a big video just on that part, and if we had a lot more time, I probably will. But we're in kind of a pinch here with time, so we're just going to try to learn to use this formula. And all this is a binomial expansion that you have studied previously, expanding this. And there's your first term. 1 minus p is your second term. All right, now here's how you read it and use it, okay? And I put this little table together for you. It says, this expansion gives the following probabilities for the occurrences of A. Now remember, A is a favorable outcome for us. And if you want to go back and talk about probability in its most, I guess, the most simple way of looking at it, really what probability is the number of favorable outcomes divided by the total number of outcomes. So we're looking at A as a favorable outcome. All right, so now remember, n is the number of trials. That's like flipping the coin 15 times. N would be 15. If we want to say what's the probability of a head, well, if head is success, then A would be 1/2, right? And that's how that would work. All right, to calculate it happening every time, use this, okay? To calculate it happening K times, which means if you're going to, say, flip the coin 15 times and you want to know the probability of getting heads, 5. K would be 5. So it'd be 15 choose 5. And you got your probability of the occurrence of the head, not head. And that's how that works. And if it doesn't happen at all, would be here. If I want to flip 15 times and I don't get a head at all, then it would just be 15 choose 0, which happens to be 1. And by the way, that's also a 1. Okay. Anyway, that's an introduction to this theorem. I know it looks daunting and horrible, but once we get to using it, I think you're going to like it. And I do have some calculator tricks for this too. So tune into the next couple of videos. I'm not sure if I can get them done in one. We'll try. But and we'll do several examples, because you're going to find some of these can get tricky when they use language like at least and things like that. Then I want to make sure we get to some of those examples. All right. See you in the next video. Hope this is helpful.